mentally math.
Let's get mental! That one was really
All
fun.
right. Okay, all right. Let's get going on this.
Yes, sir.
Take a few minutes to get out ahead of me. Okay, you should be well along with this by now. Okay, but I go fairly slowly because I'm sort of explaining it out the whole time. Okay, so this time we are actually doing a negative value of 15 minus a value of 20, so that actually ends up with a value of negative 35. Then last time I checked, 15 squared was 225. Then, hey, this is really just 3/4. And 3/4 of 12 is 9. So if you're looking at this guy, wondering what to do, you can do even better than that. You can do times 4 divided by 4. Yeah. It works. So you end up with 100 times. Because if I doubled this and half this, it works. Well, if I times 1 by 10 and divide it by 10, it works. Well, if I multiply this by 4 to get, so I'm getting 100 times something, and I'm dividing this by 4, it still works.
Well played, Mr. Gregory.
Oh, thank you very much.
Yeah, our hero.
All right, $60.
What? Oh, yeah.
Okay, then, so milligrams are 1/1000th, so this would be 25 tenths of a gram. Then this would be $3.50. That's pretty simple. All right, then for getting the average of these, I can basically take these two and think, okay, well this is like 150, and I can think of this like, hey, I could take 5. Take 5 away from this and add it to this to think like I'm doing 100 plus 70. So I can think like 170 plus 150 is 320 divided by 4 is 80. That's my mentally math path to that. But if you have your own mentally math path to that, that's totally great.
Dude, that's a good mentally math path to that.
I know, it's like I'm suddenly feeling like the Dr. Seuss of math. Oh, yeah, go ahead. Okay. Okay, so and this also, we all know what 10% is, right? So which decimal is half of 10% of 36? So 10% of 36 is 3 6/10, or 3.6, and then we could divide that in half for 1, and so I can think, 18 is half of 36, so 1 8/10 is half of 3 6/10. And that's our mental math.
It's so hard. I know, right?
Alright. Okay, so today we are talking about the area of a complex figure and the area of a trapezoid. So we've already done this to some extent with, so spoilers, we're trying to get the area of this. We have already done this to some extent well, I'll ask a question and you could perhaps answer it. Now, we've already done this with irregular figures where everything was 90 degrees. So now we're doing it with this thing that looks like a big robot foot. So, well, you've got the book right in front of you, so, I mean, anyway, so remember that we used to just take rectangles we could work with and divide them off. So what do we do in this case?
So, instead you make it a triangle.
Right. So essentially we just need to look at this and just cordon it off, partition it off for a triangle.
Or you could just do something like.
Nope. Because I think you're about to do what the book is warning you not to do.
Yeah.
Here's the thing, and so just spoilers, because I would like to say, okay, well, everyone try their own way of doing this, except the book is already warning us about.
Oh yeah, you can't do
the
right triangle.
Yes, you cannot.
Do two right triangles. Yeah.
You can't do this because, and let's see, my thing is not behaving at the moment. Hold on. Okay, let's get this up here where we can look at it closely. So as you can see, this has been marked incorrect, and this is why. Is that and it's really not obvious from looking at the diagram, but essentially this line curves a little bit. Essentially this is sort of more like that. For those watching the video, I'm walking up to the board to kind of show that the angle of the slant of the triangle, once you get up here, in order for this top one to be a triangle, you have to change the direction of the line. And that turns this into a quadrilateral, which basically turns any attempt to solve this into garbage. So you can't do that.
I see it actually. I can see it.
Yeah, it's a little bit hard to see. But,
why did they do that?
Huh? Well, I think in their example they could have made it a little bit more of an obvious thing, but I get the point they're trying to make. Okay, so that being said, yes, you will partition it off, and then get the area of each part and add them together. I'll give you a moment to get started on that, and we'll talk about how to get to that. Yeah?
Are we going to be doing shapes with like a circular, or round areas, like cones?
Oh, figuring out the cones, pyramids. I'm not sure moving forward.
No, area of like a cone.
I'm not honestly not sure.
Like cone, you just mean like.
I don't remember if we're doing that this year.
I'm pretty sure we do.
Yeah, it sounds like something we should do. Anyway, not a good use of our time to be talking about this right now.
I saw cones at the end. Yeah.
Okay, great. Then you didn't need to ask me that question. Okay, so getting my triangle, I need to figure out the height. And if this is 10 in length and this is 4 in length, then how long does this have to be? Yes.
6.
Yes.
Don't use the unsure.
Because 10 minus 4. Okay. And then to figure out the base here, if this is 16 and this is 7, Then what does this have to be? Yes.
9.
Sorry, one more time.
9.
Yes. So we'll call you 9. And then we'll not call you Fred. And okay, so knowing that, I'll let you get to the finish here. I'll take one deep breath. Okay. So I'm going to get my triangle, which would be 6 times 9 divided by 2. And you know I can do a little cross-canceling goodness here. Make this a 1. Make that a 3. So then that can get us to 27. What unit are we working again?
Wait, are you sure Bertrand did it?
We're working in... Does it tell us which unit?
Yeah, it doesn't tell us.
Oh, it doesn't tell us which unit. Okay, units.
I just put units here.
Okay.
I did 16 because I forgot to cut that thing in half. I did 6 times 16.
Okay, well, then now you know you should do that. Okay, and then the other is just 10 times 7. Oh, okay. Oh, millimeters. Okay. Well, then we will switch to millimeters. Squared. Okay, so then you just need to add those up. It's 27 plus the 70. That will get us to 97 square millimeters.
Wait, it doesn't say.
Okay, well, doesn't matter now. All right, so moving along, and well, at least we know right here, front and center. This one's in centimeters, and as far as the book is concerned, there's actually a few different ways you could divide this and make it work. So I'm going to let you try to come up with your own snazzy partitioning idea, and I'll give you a minute, and then I'll basically do what the book went with.
Wait a minute.
So you need to subdivide this into groups that you can work with.
I think I got it.
Okay, great. I think everyone is capable of doing it. That's why I'm giving you a chance instead of me just spoon feeding it to you. So, just taking a moment, letting you come up with your strategy. Definitely helps for you to copy the figure and subdivide it on your paper. Yep. Okay, gonna go about 10 more seconds. And
Oh, I got it.
so there can be one. There can be the other. Ta-da! Alright, so this one's pretty simple. We can actually Up. Sorry, gentle viewers at home. Room 16. Okay. Chuck, you are going home, pack up, and meet up with the other person. Okay. All right, moving along here. So this one, pretty basic. 30 square centimeters. This one, pretty simple. 60, except for my M. 60 square centimeters, and so we just need to figure out the last one. I spent a big game saying you could do it differently. Let's just see if your path gets you to the correct answer. I feel like I'm using a lot of extra time up right now, so is this gonna help move us forward? Okay, because I understand other people are gonna partition theirs differently, just to see how yours works out for getting the answer. Okay, and so then looking at this, that's 3, that's 10, so that can tell me that this line is 7. And this being 6 and this being 10, that can tell me that, we'll make this yellow, this line is 4. Yes?
I don't get how you got 7 for the.
Oh, well, this line, this segment side is 10 centimeters. This spot left over, that kind of coincides with this over here, is 3. So I am subtracting this length in order to get the 7.
Oh, okay.
Make sense? Awesome. Okay, so then we've got 60 square centimeters plus 30 square centimeters. And then this would be 28 divided by 2. Yes. And then, so that'll get us to 14. Squim. So getting us to 104. Am I doing something wrong?
I thought it was 84. Yeah. No, 86. Yeah, so that's 86. I thought 86. But I did it a different way.
But there's no way it could be 86 because you've already got 30.
Mr. Crutchery, take the book. It's 86. Mr. Crutchery, can I show you something?
Okay, what did I do wrong here?
Okay, so this is the pen.
Oh, wait. No. Okay. Oh, wait, no. Oh, I see. Oh, I see it. Oh, I already did this morning, too. Oh, lordy. Okay, awkward. I didn't get this line correctly. I did not subtract this part. This is also 7. Okay, which gets this to 42. Oh no, I'm going to math jail, aren't I?
I'll send you letters.
Okay. Send me letters in math jail, people. Okay, yes, getting us to 86 square centimeters. Sorry, guys. Alrighty, moving right along to part 2 of this lesson. I know. Okay, so getting the area of a trapezoid, and I sort of feel like we've already done this. But this is kind of you've got to remember this one rule. One rule, if you don't remember anything else from this lesson, remember this rule, is for a trapezoid, to figure out the area of it, you take the top side and the bottom side, and you add them together and you get the average. Yes. And then you multiply that times the height. Yes. So to get this, you've got to do 10 plus 7 Are they? Should I? Yes, centimeters. Alright, so yeah, you've basically got 10 plus 7 divided by 2. Okay, so which you get to 17 divided by 2, which will get you to 8 and 5/10, and then you multiply that times the height. So that times 6.
Because
Why 6? Because 6 is the height.
It's actually basically
Okay.
just like finding a rectangle,
Okay.
the area of a rectangle, right? Imagine 6 just being on the side, except it's in the middle. Do they always show you what the height is?
Well, if they want for you to be able to get the answer, yes.
Okay.
I mean, they have to show you what the height is in order for you to get the answer. So yeah, the rule here is add the top and the bottom. Divide it by 2. Basically, get the average of the 2. Multiply that by the height. Well, there's not that much to get or not to get. But imagine, I guess this is what if we took a little bit of the length from the top and added it to the bottom in order for the top and the bottom to be the same, so that we could just do this the same way as a rectangle.
Exactly.
Does that make sense? So essentially, if we took 1.5 centimeters from the top and added to the bottom, then both the top and the bottom would be 8.5 centimeters. And then doing that times the height would get us the area of a rectangle. Right?
It's like finding the average. It's like finding the average of the height and the base.
And so we're kind of doing the same thing if we find the average of these two.
Wait,
Yes.
it's basically like it's just a lot of shifting going on. You just like one side is much smaller, the other side is much larger, and you need to make them the exact same size. And the height being in the middle is basically the same. It doesn't have to be on the sides. It can be in the middle. It just that's all you need to find the area.
Right. So basically, the area of this would be the same area of a rectangle that was 8.5 centimeters at the top and the bottom sides, and 6 centimeters on the side. But it's not. So we just average the top and the bottom, so that it kind of equalizes that.
Mr. Richard, what they did in the book was kind of like making a line, like here, like sort of between. You see it maybe like where curvy.
Oh, I see. Yeah.
So it's like that.
Right on. Anyway, getting us to 51 square centimeters for our answer. Okay. All right. So, estimate. Estimate this guy. No, it's simple. Don't worry. Estimate this and get the area. Estimate. So, spoilers, do not do it all out with the 5 foot 11 inches and everything, and then round your answer. Round the sides, and then get your answer. So, basically, what would I round 5 foot 11 inches to? Yes. 6. So we can just put a line through that, say 6 inches. And what would I round 7 feet 2 inches to? Yes.
No, not that 7.
7. What would I round 10 feet 1 inches to? Yes.
10 feet.
10 feet.
By the way, it's 6 feet, not 6 inches.
Whoops. 6 feet.
5 foot.
Okay. Alrighty. And so now, using the rule you just learned, find the area. I will take 2 deep breaths. It should only take you a moment.
Genuinely is very entertaining to grab it.
Oh, that's nice. Well, sorry I kind of botched the last example.
Okay, I get it. I think I get it. You solve it in very efficient way.
Okay, so basically to start, we will average our top and our bottom. So 6 feet plus 10 feet divided by 2 be 16 divided by 2, which would be 8 feet. Then 8 feet times the height, 7 feet, would get you to 56
Oh my god, I need to
feet.
memorize this.
Squared. Sorry, squared. 60 squiffs. 56 squiffs. Excuse me. Yes.
I am angered by this.
Okay. All right. I'm gonna